Good afternoon, guys. So today we're going to be talking about the last form of a line that you'll see in this unit, and that's point-slope form. And I'm going to get real technical here. When I ask you when you would use it, the answer is when somebody gives you a point and a slope. Okay? It's really not that hard. They were not trying to trick you when they named this formula. Okay? So with that in mind, here is your point-slope form equation. It looks really complicated. It's actually not. Okay? So let me tell you how you use it. So first of all, M is a letter that you saw in the last lecture. M stands for your slope. So if they say the slope is 3, then where I see M, I would replace it with 3. Okay? The only other thing you actually have to fill in this equation is x1 and y1. Those are where you plug in the point that they give you. Okay? That's all there is to it. So with that in mind, let's take a look at example 1. It says write the equation of a line with the slope of 1/2, and I'm going to go ahead and mark that. There's M. Okay? And it goes through the point -1, 4. So I'm also going to mark that. Here's x1 and here's y1. So all I have to do once I identify those is to plug them into the equation. So here's my equation. Y minus y1 equals M parentheses x minus x1. So we'll start with M. M is 1/2. Okay? Then I replace x1. So I write down x minus, and then I write down that x1 is -1. Okay? Do the same thing on the other side. I write down y minus, and then y1 is 4. So something I want to draw your attention to. Look at what happened in the parentheses. There was already a negative in the formula, and then we put another negative number inside that. So you now have two negatives sitting right next to each other. Well, we know that two negatives make a positive. Okay? If they ask you for the point-slope form of the equation, you're done right there. That's point-slope form. However, if they say, I actually want you to get this in slope-intercept form, what they mean if they say write it in slope-intercept form is take this now and get y by itself. So let's say they ask you to do that. What would you do? Well, you would start by distributing the 1/2 to the parentheses. So 1/2 times x is 1/2 x. 1/2 times 1 is 1/2. Okay? Y is almost by itself except for one thing. It's being subtracted by 4 right now. So to cancel out that subtracted 4, you would add 4 to both sides. And I want you to notice something. I did not add that 4 everywhere. I didn't add it to the 1/2 x because the 4 doesn't have an x. So that 1/2 x is going to stay the same. What happened at the end here? Well, you had a 1/2 plus a 4. Well, that's 4.5. And then you're done. So here's the thing. If they ask for point-slope form, I stop at the box. If they say write it in slope-intercept form, I keep going. I get y by itself. Okay? But here's the thing. Both of those equations represent the same line. They just look really different. Alright, example 2, and this will be our last example for this video, says write the equation of a line that goes through 2 points. And you say, it doesn't give me the slope, so how in the world am I going to use the point-slope equation? Well, you're going to have to find the slope. And here's how you do that. Slope is the letter M, okay? So to find our slope, we take y minus y, that's going to be our rise, over x minus x, that's our run. It does not matter which y value goes first or which x value goes first as long as I'm consistent. So I'm going to pick this y value and put it first. So 4 minus, here's my second y value, -3. Do the same thing with your x values. The first one is a -2 minus 7. Well, what happened there on top? there was a minus in the equation, and then you had a negative number that you filled in for y. Well, two negatives make a positive. So what actually, oops, I did not mean to erase that. So we had we had 4 minus negative 3 over negative 2 minus 7. Okay, two negatives make a positive. So 4 plus 3 is 7. Negative 2 minus 7 on the bottom is negative 9. So your slope there is negative 7/9. Okay? Now that I have the slope, now I can go use my point slope equation. So y minus y1 equals m parentheses x minus x1. Okay, m is what I just found. It's negative 7/9. When I get to now filling out x1 and y1, I get to pick whichever point I want. Personally, I'm going to pick the negative 2, 4, just because it does have smaller numbers than the second point. So I say, okay, I'm using this first point, but I could use the second one. It wouldn't matter. Okay? And I say x minus x1 in this case is negative 2. On the other side, I do y minus, and then y1 is 4. Well, look what happened in parentheses here. Two negatives make a positive. So here's the thing. If they tell me write it in point slope form, I'm done right there. That's point slope. But if they say I want you to go ahead and get y by itself, then I get y by itself. So I would distribute. That's negative 7/9. And I would say negative 7/9 times x is negative 7/9 x. And negative 7/9 times 2, and you can type that in your calculator, gives you negative 14/9. Okay? You've got one more step. Y is not by itself yet. You've got to cancel out the negative 4. So y equals negative 7/9 x. And this one I'm going to pull out my calculator for as well. And I find out, let's see, negative 14/9 plus 4. So I type in my calculator, negative 14 divided by 9 plus 4. And it tells me that that is approximately 2.44. Some of you, your calculator will give you that as a fraction. You can also get a fraction in Desmos, okay? But either way, there is my equation. So this one right here is point-slope form. This one is slope-intercept form. They represent the same line, but they look very different. Okay? So that is our example of how to deal with point-slope form.